have 2D shapes, usually on an XY axis, and how we can move them or change them. Okay, so the first thing they ask us is translation. So translations just means we move the shape. Okay, so it could be you move it to the left, you move it to the right. A lot of the times they give it to you in a vector like this. So they'll say X, Y. What this means is this is how you move it to the left or the right. So they might say 2. So then you would say, oh, okay, that would be 2 to the right, or -2, that would be 2 to the left. And then Y is up or down. And sometimes they just tell you, okay, move it to the left, move it. So you just take the shape that you have, move it up, move it down. When we do any of these transformations, if we work with a shape, say, let's just say we're working with a triangle A, B, C. If you do a transformation on it, the shape that you draw once you've translated it or reflected it, you just put apostrophes next to it to show it's the image of it, so it's the shape that's been changed. A reflection is like if you're using a mirror, so you just flip the shape. Maybe it could be across the x-axis, could be across the y-axis. So reflections, we're mirroring the shape. We'll go through some examples so you'll see what these mean. Rotations means we're just moving it around the shape. So we're moving it around. So that would be if you had maybe a square here, and then you rotated it. So maybe you could rotate it in here. Okay, so you're spinning it around. And then enlargements or reductions. So enlargements, it's making the shape bigger. And reductions makes the shape smaller. Okay, for enlargements and reductions, you have what we call a scale factor. So it tells you how to scale the shape. So if it was a scale factor of 2, that means it's getting 2 times bigger. Or if it's a scale factor of 1/2, it means it's getting smaller. It's half the size. And we also have what we call, okay, so we have a scale factor. And then we also have we rotate it about a certain point, or we enlarge it about a certain point. We'll go through that in an example rather. Okay, so that's your quick recap. We're going to jump into a few exam questions just to get a feel for these, but let me know in the comments if there's any particular ones that you're struggling with. So let's have a look at this one to start with. So the diagram below shows the translation of objects A and B in the Cartesian plane. So if we just look at A, we can see here we have just A there, and then this one, it's really small actually, but we have A apostrophe. So we can see this was where it was, and then when we moved it, it became that A apostrophe. Okay, so that's what they might ask you. So this is the original. And then if we move it, this is what we call the image. So it's the shape once it's been moved. Let's see what they're asking us. So write down the coordinates of object A. Okay, so they just want, what is the XY coordinates of object A? So A, we read the X first. So A is 4, 5x. Okay, so let's just count 1, 2, 3, 4, 5x. So that's what we write first. And then the Y is 1, 2, 3, 4, 5y. Okay, so that is its coordinates, 5, 5. Now, we need to describe in your own words the translation, so the movement of object A to its image. So they want to know, how did we get it from A to that image there? So what I do with these is I usually just draw like bunny hops and count. So first of all, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so went 11 spots to the left, and then how many down? 1, 2, 3 down. So I would just literally draw on it like that. If I want to then write an answer, so describe in your own words the translation, I would just say 11 to the left, 3 down. Okay, so that just means how did we move it? So I moved it 11 spaces to the left and then 3 down. write down the coordinates of the image of B. So let's clear this up so we can look at just B then. Okay, so remember, B, the original B, is just by itself. It's just the B. So we can see here, let's get a different color. This is the original one because it's just B. So let's just write a note so we know. And then this one, it's got the apostrophe. So that is the image. So that is the one that's been moved. Okay, they want the coordinates of the image, so they want the coordinates of this one. So this one, if I look at my X and my Y, let's see, it is 1, 2, 3, 4, 5. So it's minus 5x. And then the height, or the Y, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so minus 8 is your Y. So that is our coordinates for the image of B. Okay, so minus 5 and minus 8. And then describe in your own words the transformation of B to its image. So here they say transformation. So we need to actually say, I think this one was also translated. So let's just see. Oh, okay, so this one, we could say translated, so we could say it's been translated down, but let's just check this. So this one is actually in exactly the same spot. This has actually been mirrored across here. So there's two possible answers here. You could say it has been reflected across the X, so it's been flipped over this X-axis, because you can see it's like an exact mirror image. Or you could say it's just been moved down 16 spots. So they'd have to give you either of those marks there. Okay, so let's just write down the options here. So either you can say translated, so moved 16 down. Or the other thing you could say is it's just been reflected, so it's like a mirror image, so it's reflected about the x-axis. Okay, because you can see if we had a mirror and we put it there by the x-axis, it's just flipping the B over. Okay, so that is a pretty standard question. We're going to work through a few more. Let's have a look at the next one. So we have this object here, A, B, C, D, E, F, and they say draw the image of this translated 5 units to the left and 6 units upwards. Okay, so they want us to translate this object for them. So translate means move. So we've got to move this one 5 units to the left. So I just choose 1 point. Okay, so B. 1, 2, 3, 4, 5 units to the left, 6 units upwards. 1, 2, 3, 4, 5, 6. So that is going to be my new point B. Remember, because we moved it now, it's got the apostrophe. You can do that then for all the shapes, or you just make sure you redraw exactly the same size. So it was, let's get a different color. It was 2 across here. You'll have a ruler, obviously, but I don't at the moment, so you have to deal with my awful drawing. And then it's 2 up. Okay, so that's how it's going to look. And then just when you write the labels, just put an apostrophe next to all of them. Okay, so this is the translated shape. This is the image. Okay, and then they say write down the coordinates. Oh, okay, next question now. Okay, next up we have got a triangle question. So they say we have this triangle with these vertices. So let's draw this triangle first. I'm going to get rid of everything here so we got some space. Okay, so they say A is the point 1, 2. So 1, x is 1, y is 2. So that's A. B is the point minus 2 and 3. So it's there. Let's just write these. Minus 2, 3. 1 and 2. And then C is the point minus 4, minus 1. Okay, so we have a triangle that looks like this. Okay, it really is worth it. If they give you points like this, draw them on so we can see what we're working with. You see, write down the coordinates of the image after reflection in the y-axis. So they want us to look at this y-axis. Okay, and they want us to look at this line, and they want us to reflect the shape across this line. So it's a little bit tricky to think about. If I want to reflect it, what I do, instead of trying to draw the shape, I just try to reflect each point. So if I reflect C, I'm going to move it across the y-axis. So it's going to go to this side. What you need to do is make sure it's exactly the same distance from the y-axis. So here it was 4 across. So now it's going to be 4 across on this side. Okay, and the height has to stay exactly the same, so it doesn't change height. So our new point then is going to be here. So C is now going to be 4 minus 1. If I do it for all the other points, let's see. So B again is also going to come across. So B was 2 across here, so it needs to be 2 across here. So then my new B point is going to be here. It's going to be 2 and 2 and 3. Okay, and then last of all we need to do A. So A was on the side, so it's going to have to move across to that side. So A, let's see. A was 1 across here, so it's going to be 1 across on the side. So this is going to be our A now. Okay, which means we've got minus 1 and 2. Okay, so this is our reflected triangle then. Okay, so you can see it is a mirror image. That's how it would look if you put a mirror between them. It is a little bit tricky to see that reflection, so that's why I just do each of the points. I look at the line and I just reflect it across the line. Now we have these points, so we can, if you didn't know them, you could just read off. So if we want these points, so A now is going to be minus 1, 2, we said. B, the image of it is going to be 2, 3. And C is going to be 4 minus 1. Okay, I think that is all of that question. Let's keep going. Here we've got the coordinates of A are minus 4, 3. So I'm just going to write this on because it's useful to just have it with you there. So the X is minus 4, the Y is 3. Write down the coordinates of A if A is a reflection of A in the x-axis, okay? So here is our x-axis. So they're asking us reflected across this line. So we are going to imagine a mirror, so it's going to be somewhere down here that we're going to be reflecting it. So exactly the same as before. If we're reflecting it down there, we've just got to check. So there was a gap of 3 there. So now it's going to be 3 below. 1, 2, 3. Okay, but it still has to be exactly in line. So I'm just going to draw it here. Now we'll just do it in red. So that is going to be our new A coordinate. And so it's still at the same x coordinate, but now it's at minus 3 instead of positive 3. Okay, so A, the image of A is minus 4, minus 3. And then they want us to do the other one. So they say, what is the image of a reflection in the y-axis? So that means we're looking at this y-axis and we're reflecting it across there. Okay, so similar, we're going to see what was the gap here, what was the distance? So it was a distance of 4. So we're going to do 4 on the side. Okay, and then that's going to be the image. So we can say then that image is going to be positive 4x and then still 3y. Okay, so that is 4 and 3. Okay, this brings us to pretty important points. So if you reflected about the x-axis, let's just write this down somewhere. I'm going to write it down on this page actually. Okay, so if you reflect it Okay, so if you reflected about the x-axis, so that's like we did in the first one, the x-axis, your x value stays the same, but your y value changes. Okay, and it's actually just the sign in front of the y change. So you'll sometimes see it written like this. So you'll have x and y, and then when you get the image of it, then you have x stays the same minus y. So that is how you would show a reflection. Okay, the other thing is if you're reflecting it about the y-axis, it's the opposite. Okay, so if you reflect it about the y would stay the same, but the x sign changes. Okay, so that's just something useful to keep in mind. Let's have a look at, I think, do we have any other ones here? Okay, write the coordinates of A3 if it is rotated anti-clockwise about the origin. Okay, so let's just clear this up a little bit. Okay, so now they're saying we want A3, and how we get that is we rotate it anti-clockwise around the origin. So all they're saying is we're spinning this around the center here, around this middle point. We're going 180 degrees anti-clockwise. So that's this way. So if I went 90 degrees, it would be down here. Let's see. Okay, so that would be 90 degrees. So then if I wanted 180 degrees, it's going to be in this quadrant here. So let's just see, it was 1, 2, 3. Yeah, so it's actually going to just be a line here. So let's see, 1, 2, 3, 4. 1, 2, 3, 4. So that is going to be your A3 point because I've spun it then 180 degrees. Okay, which makes sense if you look at that. Sorry again for my drawing. Okay, so rotation just means I take that point and I just spin it around. When you're working with the XY axis like this, every one is 90 degrees. So 90, and then, so if I go like that, it's 90. If I keep going, it's 180. If I keep going, it's 270. And if I keep going, it's 360. So just keep that in mind.